Alright, so in this video we'll work through the Chapter 12 practice test, and you can see the topics right there. The whole chapter is about trigonometry. So 12.1 involves finding the values of trig functions, and in these cases they've given us the triangle, but in a couple other examples we'll see they haven't given us, we'll have to draw one. So we can use this acronym SOHCAHTOA, which means that sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So they're asking us for the tangent of this, which is opposite over adjacent. They don't give us adjacent, but we can use the Pythagorean theorem to find it. So 20 squared plus we don't know squared equals 25 squared. When you subtract 20 squared from both sides, this other side turns out to be, this is 625, and this is 400. 625 minus 400 is 225. So if x squared equals 225, then when you square root it, you should get x, and it turns out to be 15. That means this side is 15, so tangent is opposite over adjacent, or 20 over 15, and that as a fraction reduces down to 4 over 3. A tangent should be 4 over 3, and it turns out to be just that. Alright, cosecant is actually the reciprocal of sine, so we can find sine here and then just flip our answer around. So sine, according to SOHCAHTOA, sine is opposite over hypotenuse, which we don't know. Okay, so we can use the Pythagorean theorem again for this. So 8 squared plus 6 squared, that's 64, plus 36, which turns out to be 100. And 100 is the same as 10 squared, so this is going to be 10. Sine is opposite over hypotenuse, so 6 over 10. That means cosecant is the reciprocal of that, 10 over 6, and that reduces down to 5 over 3. Okay, in this case they ask us the same question, but they don't give us the triangle, so we'll have to draw our triangle right here. So here's a right triangle. Let's call this one theta. It says secant is 5 over 3. Remember that secant is the opposite of cosine, so we know that if secant is 5 over 3, cosine would be root over 5. And cosine is adjacent over hypotenuse. So if I look at this angle theta, by the way, you didn't have to put the theta there, you could have put it up here also, but that's kind of the typical way that we put it. So cosine is adjacent, which is 3, over hypotenuse, which is 5. And if we use the Pythagorean theorem again and solve like we did before, we end up with x squared equaling 16, which means that x equals 4. Okay, so that's what our triangle looks like. It says find tangent, and tangent is opposite over adjacent, or 4 over 3. And so that should be what the answer is. Oops, you can't see it because it's written over, but yes, 4 over 3. This one right here, same thing. It says they're giving us cotangent, and cotangent is a reciprocal of tangent. So let's write down what tangent is. Tangent is going to be the reciprocal of this, so 39 over 2 radical 13. So let's draw our triangle right here. Here's our theta. It says find cosecant. Well, cosecant is related to sine. Sine is opposite over hypotenuse, so that means this one is going to be hypotenuse over opposite. Alright, let's fill in our triangle. So tangent is equal to opposite over adjacent, so opposite would be 39, and adjacent would be 2 radical 13. And then we'll use the Pythagorean theorem again. So 39 squared plus 2 radical 13 squared. 39 squared is 1,521. 2 radical 13 squared, 2 squared is 4, and radical 13 squared is just 13. So 4 times 13 would be 52. And then when we add those together, we should get 1573. Let's see here. If we do this correctly though, adjacent over opposite, so 1521 plus 52, this should be a perfect square. For some reason it's not coming out to be one, so let's keep going, maybe we'll discover if there's a mistake somewhere. So that is going to be equal to the hypotenuse squared. So if you square root that, square root of 1573 is what the hypotenuse is. I think the reason that's not coming out to be exactly right is because we can actually simplify the square root of 1573. We'll look for a perfect square that goes into 1573. I see this 13 here, so I'm going to guess that 13 probably goes into this somehow. 13, let's see, how many times does that go into? That goes in, I think, 210 times, if I'm not mistaken. So no, it's got to be less than that. I think it's 100. So 13 times 100 is 1300. That leaves over 273, which is 21. So that actually goes in 121 times. So basically we're looking for perfect squares. That's a perfect square. So this is the same thing as 11 radical 13 as our hypotenuse right there. And again, the way I knew 13 was going into it was because I saw that that other leg was 2 radical 13. So that's usually a good hint or a good indicator. Okay, now we have everything we need. It says find cosecant, which is hypotenuse over opposite. So there's the hypotenuse, there's the opposite. So 11 radical 13 over 39 should be the answer, and it is. Okay, these ones right here ask us to find the measure of each angle. So we want to find the angle theta, and they're giving us adjacent right here, and they're giving us hypotenuse. And if you remember from SOHCAHTOA, the cosine is adjacent over hypotenuse. So we could say cosine of theta equals adjacent 7 over hypotenuse 12. And now we want to find what theta is, and we need to cancel out the cosine. Remember that you can't divide by cosine. Cosine is not a number, it's a function. So the way to cancel out cosine is by taking inverse cosine. So those will cancel. And the inverse cosine of 7 over 12, let me just show you how to do that in the calculator. You need to make sure that you are in radian mode. So let's just double check. Sorry, degree mode. I meant to say we're in degree mode. So we're good to go. We do second inverse cosine of 7 over 12. And let's see what we end up with. We end up with 54.3 degrees. And that looks right. They said round to the nearest tenth. Okay, number 6 is a similar type of thing. It says find the measure of a missing side this time. So this side is opposite, and that's hypotenuse. And opposite over hypotenuse is sine. So we could say the sine of 24 degrees is opposite x over hypotenuse right there. We want to solve for x, so we see what's being done to it and do the opposite. Right now it's being divided by 15.1, so we're going to multiply by 15.1, which means we do the same to this side. And when you put this in a calculator, that's a 15.1, write that a little bit clearer. 15.1 times the sine of 24 degrees should give you that number right there. And it's a good check to make sure this number is smaller than the hypotenuse. If you had gotten a number bigger than 15, you know something went wrong, because the hypotenuse is always the longest side. Alright, these involve 6 or 7 and 8 involve converting either degrees to radians or radians to degrees. So we need to know that 180 degrees is equal to pi radians. Since we're in degrees right here, we're going to, in our fraction, we'll put degrees on the bottom, and we'll put radians on the top. The degrees will cancel. 30 goes into that 6 times, and it goes into that 7 times. So we should get 7 times pi over 6, 7 pi over 6. Okay, this one will do the same thing. The only difference is now radians are going to go on the bottom because we're given radians to start with. So the radians will cancel, and 180 degrees per radian, so the pi's cancel. 6 goes into itself once, and it goes into that 30 times. And 30 times 5 is 150 degrees. So there's our result. Alright, the last 2 problems on this page. Coterminal angle means an angle that ends up in the same spot. So for example, if I have this one right here, negative 390, negative means we should go clockwise instead of counterclockwise. So here's 0. I'm going all the way around. That's now at 360. And so I must go an extra 30 degrees past 360 to get to negative 390. So that's going to be right here. This entire angle right here. So all the way around, and the second time that's the same as negative 390. To get the coterminal, you can just keep adding 360 until you get a positive number, because we need a number between 0 and 360. So negative 390 plus 360 is negative 30, still not positive. Let's add another 360, and we get 330 degrees. And that makes sense because we went an extra, use a different color here, we went an extra 30 right here, we went 30 this way. Well, if you had gone the other direction, that's almost all the way around except for 30. 360 minus 30 is that right there. So we should get 330 degrees. That's the only coterminal angle. Okay, this one says find both types of angles, a positive and a negative. So we can do that by adding 360 to get the positive, because negative 45 is about right here. That's a negative 45. So if you went all the way around, back to where you started, that's like adding 360 and you get 315. And then if you go the other way, if you're at negative 45 and then you go Actually, I went the wrong way here. It should have been, that should have been 315. The orange one is 315. And the other one would be 45 minus 360. So I hope those colors, unmatching colors, don't confuse you. They're supposed to be opposites. But all we did was add and subtract 360 to get those two angles right there. So 315 and negative 405. In the next video, we'll talk about how to find the arc length of an angle using circumference as the main component.